Alright, today I'm going to talk about two more rules. We have the chain rule, which we most recently discussed, and then we have what's called the power rule, where you have some variable raised to an exponent, like x to the fifth or x to the negative 1/2. Those are the two rules we have so far, and we're going to have two more. Product rule and quotient rule. Product rule, you need to recognize when to use that. You're going to use the product rule whenever you have two functions that are being multiplied together to create your bigger function. And that's what I have here. I have two functions multiplied together, and I need to find the derivative of this whole thing. So what I'm going to do is I'm going to call the first function f, or f of x, and I'm going to call the second function g. And to take the derivative of this, I can't just take the derivative of f and multiply it by the derivative of g. That's going to get me some bad answers. So there is a rule that's in place. This rule has been proven, and if you want to see the proof of it, there is a separate video on that. So to find the derivative of this function, here's what I'm going to do. I'm going to take the derivative of the f part of the function and multiply it by just the g part without taking the derivative, just leaving it alone. And to that, I'm going to add just the f part without taking the derivative times the derivative of the g part. So there's two things being added, and in each part I'm taking the derivative of one piece of this bigger function and leaving the other piece alone. So that is the product rule. So let's use this example, and I'm going to use my dy dx notation. So dy dx, which means the same thing as f prime of x, or find the derivative, or find the gradient, or differentiate with respect to x. All of that means the same thing. I'm going to take the derivative of the f part, which according to the rules you know, is 5x to the fourth plus 9. And I'm going to multiply that by the g part, but I'm not going to take the derivative of it yet. 3x to the 7 minus 2x squared. Alright. And to that, I'm going to add kind of the reverse of that. I'm going to leave f alone, so it stays as x to the fifth plus 9x. And I'm going to multiply that by the derivative of the g part. So now I'm going to use the rules I have to find the derivative. 21 x to the 6 minus 4x. Alright, and yes, you could FOIL out each pair of binomials, add them together by collecting like terms, and get something that looks much nicer. And I could have done that earlier. I could have FOILed out the function before I even took the derivative, and took the derivative in a much easier way, but I am just kind of showing you how the rule works, and no matter how you do it, you should get similar answers, because no matter how you express the function or how you express the derivative, they should be the same. Every expression of the function should be equivalent, and every expression of the derivative should be equivalent. Alright, so that is the product rule. Okay. The quotient rule is similar. But instead of having two separate expressions that are being multiplied, I have two separate expressions that are being divided. And to do that, the top looks very similar to what it did in the product rule, but I'm subtracting instead of adding, and now I'm dividing by the square of what was already in the denominator. So what I'm doing is I'm taking the derivative of the top and multiplying it by the bottom, and then I subtract the top times the derivative of the bottom, and I divide the whole thing by the bottom squared. So I'm going to do this example here. I should probably leave myself a lot of room. So dy dx again is, I'm going to take the derivative of the top, which is 5x to the fourth. Notice how I'm using the same expressions from the last example, so that things look a little familiar. 5x to the fourth plus 9, and I'm going to multiply that by the bottom. 3x to the 7 minus 2x squared minus the top, which is just x to the 5th. I'm not changing the top, just leaving it alone, times the derivative of the bottom, which is, again, 21x to the 6th minus 4x, all over the bottom squared. And I'm just going to write that as 3x to the 7 minus 2x squared squared. Okay? And again, you could simplify that by, distributive property here, squaring a binomial on the bottom. You could do that. It may make it look nicer. But at this point, basically getting this unsimplified fraction is good enough. The rest of it is just algebra until we actually use it for something else. So that's the product rule and the quotient rule, and if you have any questions, please email those to me. Also, if you want to see the proof of these rules, that will be in a separate video. Other than that, we will practice this tomorrow.